Okay, so to start, I just want to review a theoretical background to breathing and airflow and those lung volumes and vital capacities and lung capacities. So essentially we understand the mechanism of respiration, that's the muscles that help in respiration, in this case the diaphragm and the external intercostal muscles and the accessory muscles, including the sternocleidomastoid. Those muscles are the ones that are employed in respiration, and essentially when the diaphragm contracts and relaxes, it increases or reduces the volume of the thoracic cavity, and when that volume changes, it creates either a negative pressure when it's increasing and it creates a positive pressure when it decreases, and by then that mechanisms allow air to go into the lungs and causes ventilation. I know we already know all of those, but just to check that with the external intercostal muscle and the abdominal muscles and accessory muscles. Now, something that we may just need to reflect upon is the concept of resistance to airflow, because in the course of this experiment we'll be talking about airflow. And when we talk about airflow, we are looking at the change in pressure between 2 points and the resistance. So during the experiment we'll have a look at that, but suffice to know that when there is an increased resistance, the flow of course would be what? Reduced. Is that not? Yeah, so, and when the resistance is less, the flow will be more. And of course we can recall that at the upper part of the respiratory tract there is more resistance, and so the flow will be more turbulent and will be less, but the resistance also reduces as you go deep through the respiratory tree. So that's just what I've just said. Essentially, the mechanism of breathing, which I said earlier on. Please pardon me if I'm moving too fast, but you can stop me. Too fast?
Yeah.
Okay, thank you. And this is the units that we are using for this experiment. Essentially, this is where I want to pause, and this is where I'm coming to. So when we breathe normally, the rise and fall of the lung volume is what we describe as the tidal volume. Then from that position, so this is what we see here, the usual rise and fall. And from the tidal volume, if we breathe to the highest capacity that our lungs can take and breathe in, that is the inspiratory reserve volume. So it's more like going into the reserve. And if that is reflected for expiration, that is the expiratory reserve volume. I know we are, of course, very familiar with these things, but just to revise that we have inspiratory reserve volume, the tidal volume, expiratory reserve volume, and residual volume. Of course, the lungs cannot be completely emptied. Yeah, so that's the residual volume. The next thing is capacities. So lung capacities, if we combine one or two volumes together, that gives us the lung capacities. So if we look at the the tidal volume and the inspiratory reserve, okay, and we can see that together with the first expiratory volume, which is the first vital capacity in the first second. So we'll look at that for 1 second. We'll also look at that for the ratio between FEV1 and FVC ratio. All of this we will check, and essentially what's the target is for us to be able to identify restrictive and obstructive conditions of the lungs. And by obstructive, we should, if we have the time, we should be able to simulate asthma with this, and we'll try to cover this and put a puncture and just see how we can simulate asthma if we have the time. But I mean, if we don't have the time, we can just play around the data acquisition and how to make sense of the data that we have acquired. Right, if you would permit me, then I would like to stop the introductory section here. But do we have any questions? Was there something that looked too fast that I jumped over? If you have any questions, you can let me know.
We need to jump to the experiments.
Straight to the experiment. Thank you. So can we have a volunteer? Can somebody just volunteer to... Perfect, thank you so much.
Oh, he's been so reluctant to be volunteer. I don't know why.
People are quiet. I just had to volunteer. Yeah, because my values are not so good. I have to keep that confidential.
Thank you very much. Well, I didn't mention that the volunteer will leave here with a so thank you very much for coming, and there is a little token to really say thank you for being a volunteer. Right, so we want to perform the pulmonary function test on our volunteer. We want to measure and analyze the PFT, such as the forced expiratory volume in 1 second. And we want to appreciate how it feels to breathe with constricted airway. Well, I've said that for this lab chart, it is self-explanatory. And I may want to take the risk for somebody to come and run the test, but we'll definitely spend more time. Can we agree to that?
Yes.
So somebody should come here and do the procedure?
Continue.
I should continue? Perfect, good. Right, so we are moving on. Just to, stimulate our thinking. I want you guys to direct me, because I deliberately skipped this when I was doing the introduction about static and dynamic categories. So we can play around with it, and from here just understand what it means. Now we have to drag and drop and look at which of these parameters. Yeah. So tell me where I should take this one, first or second? First. Good. Where do I take this to? Where do I take this? We are not sure, so should I throw it away?
That should be dynamic.
Okay.
No, it's dynamic. You change with time.
Right. So what about this?
You change with time.
What about this? Static? Residual volume?
Static.
Tidal volume?
Dynamic.
No.
Dynamic? Vital capacity?
Dynamic.
Dynamic? Any objections?
No, check.
It's a tidal volume of course.
Yes?
I think the vital capacity and the total volume, they should be static.
Everything.
Okay. Well, if I put it there and everyone feels it, I hope you know who is responsible for it. I'm just joking, please. And if he gets it, if everyone gets it, it will help us to just provide a little bit of insight why it is that. So let's take the risk. It's about taking risk. So let's take it.
And also the first is
Oh, we missed that. Right, so would you just want to tell us why you have moved this and this?
the static ones, they are just measured the volume you will get if we breathe normal, or we breathe excess to normal breathing,
Yep.
regardless of time.
Right.
But for example, for the first expiratory volume, is the volume that you need exhale forcibly after maximum inhalation in a given time period, maybe in 1 second, that is of if you want. And
Right.
if it is more than about 6 seconds exceed the FVC.
So essentially the difference between these two is that one has time factor in acquiring it. So that's why we see static and dynamic. So that's the answer for what we find here next. Now we're going to look at the setup, and this is a very good thing about any instrument software. Nothing is hidden. Even if someone is a novice, you can play around the configuration. Well, I have done this while waiting, or else I would have loved somebody to come and watch this video and follow through with the video. So that is a Power Lab unit, and we have a spirometer pod here, which is a signal conditioner, and that's what is connected to the Power Lab unit. The spirometer pod is then connected to a flow head, and you will see that in a moment, with connecting tubes. and then the tubing, and then the respiratory filter, and then the mouthpiece. Well, I have one for myself, and these have not been used, so for the 3 groups I've gone with 3, so we can use one per group. I have an extra one that a gentleman that was here with me while waiting used to check the system. Yes? Any question?
No, this one.
Good, fine. So that is how the setup is, and there's also pictures for what we have done. So we have the parameter port, the flow head, the port tubing, the filter, and the mouthpiece. So sir, if you want to take one of the mouthpiece, we can follow the procedure. So I think we can walk through it together. Right, so now leave the flow head apparatus on the spot, on the stop, on the bench, and select 0. Now for lab for lab station interface, we have the data display panel, and we have instruction by the side, and some other pages will have analysis, tables, and all of those things. Right, so this is the display panel. This display panel will allow us to take flow. We can see, remember we talked about flow as changing pressure and resistance. So we'll see volume on the display panel, and we will see the respiratory rate. So these 3 things will be taken simultaneously in this experiment. Well, clinically it may not be exactly like this, but the science is the same. And why we have adopted this pattern is to allow students to be able to understand the science better. Right, so we leave the board with 0 so I'll go ahead to do that. So ask the volunteer to put the nose clip, if possible leave the nose clip on in the entire lab. Well, sir, this may be a little bit discomforting, but thank you for volunteering, and just keep it and see that. So you have to breathe through your mouth. Now ask the volunteer to put the nose clip, if possible leave it there. This is to ensure that all air breathed passes through the mouthpiece and through that. So I have zeroed this already. And the next thing is to connect the mouthpiece. Because we are instructed that we should start recording before we connect the flow head. So I'm going to click on start. And we can see the readings on display without any signal. Then you can connect it. So you can take this one. I have this just for example. So what we want to do, we are putting this one in front of our teeth and then wrap our lips around this. So this would not go behind the teeth, and you would ensure that the tongue, you can breathe into your mouth. So you can ensure that the tongue doesn't also obscure this hole. So I'm going to show you a sample. Perfect. Thank you. So you are expected to breathe normally and just get used to it. Now we talked about the tidal volume.
Yes, they will notice when we face with the students that it don't look like the children look small.
Yeah, so I'll click on stop. Thank you very much. So, well, we can do the auto scaling. We can do auto scaling from here if you want to, and that shows us the. I know it's quite difficult to breathe normally when you are asked to breathe. But when you are we often forget that we are breathing anyway. But when you get the consciousness that you are breathing, then some of the things will change. Essentially what we are doing here It's just to get the system accustomed with what we want to do. So we have not started the experiment here. So we have zeroed the inputs, and we have just done this. And when the volunteer has become accustomed to the apparatus, we click stop and wish what we did. Now make sure the volunteer keeps the nose clip on and breathes through the mouthpiece, and wish we did. Again, we move to the next page. We want to correct volume, because there are chances that the volume could have, since we are doing it for the first time, could have some interference. So we want to correct it now. And first thing, re-zero this parameter pod using the zero inputs. Right, so this is what I'm doing here. Remember that the flow head must be left undisturbed on the bench during the zeroing. Of course, we have it undisturbed. Select start before we ask the volunteer to pick up the flow head and start breathing. Now, we want to get another baseline value. Right? Yeah, so you can pick it up. And start breathing. And we should keep this for 1 minute. 1 minute. Of course, Power Lab allows us to add comments to the data that we are acquiring, so we would include volume correction. So I add that. We have our time at the x-axis, so this is 40, 45. Right, and there we go to stop. Thank you. Yes. Well, we should have gotten the bottle of. So, what's the response from Mambo? Wow. And Karibu. Okay, right. So I'm very excited to have this opportunity to have this chat with us, because if we look at the profiles of people that we have here, and myself, I mean, it's just not matching. And of course, I understand that we have a mixed group. Some could be at the far extreme of their profession, and some could be at the middle of their career. Some could just be starting. So it's a very good thing to have this kind of mixed group, and it would be nice for us to share as much as we can. So a very good morning to us, and to welcome us to this session in spirometry. My name is Myro. I am a Nigerian, and I did my undergraduate and master's in Nigeria. And I currently live in the UK. I went somewhere else to look for money and got some money, and then moved to the UK. And currently, oh goodness, well, I hope to. And I work in instruments as the distributor supports for Europe and Africa. So what I do essentially is that we have distributors across different parts of the world, and we have distributors in Europe, we have distributors in Africa. So my team, we provide support for distributors. So should they need technical support, maybe with our software or with our hardware, or they need any form of updated or training, we provide such for the distributors. So I essentially provide that. I'm avoiding to use the word technical support, but because it's more than that. So I provide support for distributors across Europe and Africa. And you've seen the other members of my team. Federico, who is outstanding with his beards. I mean, he's the manager for the distributor network, so I'm in his team. And Timo, who is the other German man. He's the general manager for Europe and Africa. So I'm very much excited to be with us today. Well, I deliberately tried to avoid talking about my background, but I have a background in medicine and surgery, and I have a master's in physiology, and now I have transited into something that's related to tech and business, obviously for reasons beyond the scope of this meeting. Well, I would have loved to know every one of us, but I see that we are behind time. It would really be nice to have us introduce ourselves, say a little thing, and at least to have the room to be relaxed. But if we try to do that, we could just lose so much time. And this spirometry session will end up with introductions. I'm sure we don't want that. So, welcome everyone. Well, why are we here? And that's what we have on the screen. Professor Tony McKnight is the founder of AD Instruments, and he has a very strong passion to make an impact in the teaching and training of physiologists. And he also had a very soft spot for Africa. And he has done a number of donations with regards to what we do to Africa. And sadly, Tony McKnight passed on very recently, and we are here to continue the good work that he has been doing. And that is why, we have come with the senior managers in the company, and they are not salespersons. The managers that came, they are real senior leadership team, and because we knew that if Tony was around, he would very likely be here. So that is the reason why we're here. And one of the good things that just want to quote something from Tony's legacy. So you can just find that on the screen, that he has this soft spot for excellence and innovation. In fact, he wrote this collection of physiology that is called Understanding Your Physiology, and later on transposed it in such a way that it will be an active learning platform that allows students to drive their learning process. So that is the reason why we're here. And today, of course, we want to have a look at spirometry. Well, maybe if for the purpose of this discussion, if we can just put aside what would bring walls between us, between you and the person beside you, or between you and me, if we can put that aside. For example, if you notice, I introduced myself without a title, so sometimes title can be something, or your location, where you have come from, or your preferences and all of that. If you can just keep that aside and have a unified mind that we are here to learn physiology, because I know that we are a diverse group, so we can interact very well. I would like to start by talking about what is AD Instruments and what is a Power Lab. Can I ask if any of us is new to the Power Lab? Is there anybody that is new? So I can skip that because everybody knows the Power Lab. Is that so?
You can give the introduction.
Okay, overview, thank you. So now the AD Instruments, it's a world-leading provider for hardware and software technology for education and research. And we provide the Power Lab system, which is the hardware. We have the Lab Chart, which is the software that allows for active learning in education, but for research, the software allows for data acquisition and also for data analysis. So that is that. The Power Lab unit essentially allows multi-parameter data to be acquired. So if you moved at the end of the day from this room to another room, you will still see the Power Lab. But the difference will be the kits that comes with it. So for this, I have the spirometry kit. When you move to EEG, you will find the EEG kit connected to it. and when you move to ECG, you'll find the ECG kit connected to it. Now, of course, we have kits across different systems in the body that you could do our experiments with. I hope that is brief enough. What you have on display is the lab chart interface. So this is our software interface. I mean, if I wanted to open this, I would come here. You can see that it has an icon on the desktop, and just double click like you would open your PowerPoint or any other software that you have. Or
The ND you have to buy it, is it?
yes. So the software, when you buy a system, the Power Lab system, it comes with the hardware and the software. It is sold together. So with the software, you can see what the hardware is acquiring on the computer. Now, so I've opened this is a lab station teaching software. So I've opened the lab station software. And it may be new to some of us, but just to mention that it contains instructions to help the participants, in this case, very senior professionals.
The icon itself is explanatory.
Exactly. Very well. Thank you. So it is self-explanatory. It gives you the direction. It provides a background data. So this is the test we want to do today, is parametric test, and I've opened an interface to provide a background to this. So please pardon my timing. I mean, we are 3 hours behind. So can I assume that we started at 11:15? And we can work towards stopping at 12:15? Because we had intended for 2 hours, but obviously running late, and let's see the little that we can do. This is a region selection, and this is point selection. Of course, in case you don't know it, if you are the first time user of Lab Station, you can click on this and it shows you what the comment panel is, and then you look for it here. That is it. Now let's assume I'm a first time user and I don't know where compression buttons is. So since it's in blue, I'll click on that and I'll find the compression buttons. So you can increase or reduce. There's a scroll bar. I will assume I don't know that, and just right here at the bottom. So we can essentially move back to where we started and move forward to the scroll bar. Now use the region selector. Assuming I don't know what the region selector is, I have to click this, and this icon for point selector and icon for region selector. We will need all of these tools when we get to the point of analyzing the data that we have acquired. Right, so it says that use the region selector to select the regular breathing. Right, so this is the region selector. It has appeared now on the data panel, and I want to take it for the entire regular breathing, which is now being highlighted. Right? Do not select the areas of zero flow at the beginning. Of course, I didn't do that. I mean, I just skipped it because I already knew. So you can see that this is where the area where there was a zero flow. Now, at this point, we want to calibrate the spirometer and we'll be ready to take data. Good, so our spirometer has been calibrated, and this will apply a volume correction. So if for volume, we need to fill in the spaces, FEV1 and forced expiratory volume, where does it start, forced vital capacity, and I want you guys to direct me on what to do. So
Sorry, if you can go to the previous slides.
Yeah.
So from where can I get the flow rate if we want to measure the volume of tidal volume?
So if you want to check tidal volume, so this is 0, right, and this is 2 liters. So somewhere in between would be 1 liter, and if you come less, it should be 500 mils. And of course, if you want to make that clearer, we can increase it so you can see where 1 liter is. So just in case you want to actually see the 0.5, so you can see
It should be
that.
much more clear.
Yeah, so it's just about adjusting the display, and of course we know the value of tidal volume. Maybe we just need to check if Dr. Ozone is within what is expected, and congratulations, it's within what we expected. I think this is clear enough. Can we go on?
Yes.
Perfect. Right, so let's play around this. We have acquired, let's assume we've acquired the data that looks like this. Where do we, right here?
No.
Right here?
Yeah.
Good. So it's a way of regression that inspiration is positive waves and expiration will be negative waves. So this is a negative wave. I mean, if you want to look at it here, so when our volunteer was inspiring, we have a wave that goes up like this. When it's expiring, it comes down like this. And if from this point we want to check how the maximum volume that it would have when it inspires, we'll have something that goes up like that. Right, so we will see all of this in the course of this presentation. Now let's assume that we have asked our volunteer to breathe from the tidal volume level to expire as much as he can. So let's say we have asked him to expire as much air he can expire from the lungs. So from breathing in, out, and asked to expire further. So are we going to get a more positive deflection or more negative deflection?
Negative.
Right, so where does that start?
There.
Right, so we can see that this is around the tidal volume where we get our data. So from here, there's a force from the level of tidal volume, the force expiration starts there. Now we want to look at FEV1. So that is the force expiratory volume in the first second. Where do you think that would be on this? Right here?
Yeah.
Good. And we want to look at FVC. That's obviously the last one standard. And again, if we remember what that means, that is when from tidal volume, the normal breathing, then you take a maximum inspiration and then blast it out. Right, so, and then we'll check all of those. Just to check our answers. Yes, of course. Exactly. Because, yes. I mean, if in contrast to some other conventional systems, they will just do the experiment and print a sheet of paper and go away. But we can do some level of activities and get more information.
It was not as friendly.
Yes, LD, we only have the hardware,
Yeah.
but our software, as Dr. Farai said,
Lab features.
it was lab tuned earlier. So when we update it,
Yes, of course. And of course, I didn't mention that at some point I was lecturing on the graduate medical students and I was using the lab tutor. But I mean, now the coin has been flipped and I mean, I'm no longer a user, but right here, yeah, I mean, doing business. So that is that. To move on to dynamic function testing, and this and the next slide is where we'll find the meat of the matter. But so far so good. I said, any question?
The only problem is that the subject is having to struggle to maintain that airflow.
Okay, well, I'll show you. I just didn't click
It should
that.
have a support, it should have an
Yeah,
independent support.
so the support should be like this. This is the way to put it.
When you get tired of doing that, that's
You
why.
get tired, you should have a support.
Well, I agree with you. And of course, in the clinical setting, I mean, if you people that want to do this spirometry test, they just go and sit down in front of the mouthpiece and do it. But this again is designed in such a way to allow students to see all of the components that bring about the data that they have been acquired. Well, thank you for that very, very insightful comment. I agree with you that maybe we would have gotten a stand, and so that the volunteer would be more relaxed. Right, so at this point we want to see dynamic function testing. The question here is following maximal inspiration. How long does it take to expire as much gas as possible from the lungs? So we want to take in maximally and then breathe out, empty everything out. How long will it take? So that's what we want to check. Somehow along the line we will see the relevance of that in checking the lung functions. Because some people will take longer time, some will take shorter time. But this software will allow us to see how that comes about, because we'll see the timing and all of the recordings alongside. The answer to this question gives us important information about the person's respiratory function. So the first thing we want to see is how long it will take to expire all of the air out of the lungs. Then we will now, from that, we will check what happens in the first second. Is it making sense to us now?
Yes.
And of course, if you want me to repeat anything, I'm going to get just. Now, so your data from the previous activity has been transferred to this page. Therefore, you do not need to perform volume correction. What we need to do now is to follow the procedure. Zero the spirometer cord. We have this here. So zero it. Remember that the flow head must be left on the stop on the bench during zeroing. And that is what we have. So the volunteer does not need to carry the flow head while we are zeroing the cord. Select start to record. Ask the volunteer to breathe normally for approximately 30 seconds. So he will get set, and I will start, and then you would get it connected. So we are going to get these values for 20 seconds, just for us to see what we need to see, and we need to compress this a bit. Now prepare FVC comments, so I have to put FVC here, FVC procedure. Ask the volunteer to slowly inhale, no more air, until no more air can be inspired, and hold for 1 second. So slowly breathe in, hold for 1 second, and forcefully breathe out. Empty it completely. Good, thank you. You can stop. Well, I think that was too fast. I would have allowed him to breathe normally. I noticed that I was already stressing him and I needed to stop, but we should have allowed him to continue to breathe normally so that we can appreciate the return to tidal volume. We can do that again. Right. I like this one.
Second and then now expire.
Yeah, so that's the procedure. So you breathe normal, then take in maximally, breathe forcefully out continuously until everything is empty, then return back to normal.
Then I hold it when I'm out, then
Yes.
I hold it.
Yes.
Till I got hold it.
Yes.
After expiring, I hold.
After expiring, you hold for 1 second
Yes.
and forcefully breathe out.
After expiration.
After expiration, return to normal.
Without holding.
No, return to normal. Right, so start breathing. Ten seconds, 15 seconds, 20 seconds. So now breathe in, maximally, slowly, steady, breathe in. Hold for 1 second, forcefully out, and continue to breathe normal. Right, so that's the comment. We're going to repeat this for 3 more times, so just continue to breathe normal. When you are comfortable to do it, you breathe in, hold for 1 second, and breathe out.
As fast as you
Return back to normal breathing. So continue. All right. Thank you very much. So I'm going to stop here. Thank you very much, sir. If we look at this display, what we have on the screen, and go back to this thing that we played around, can we find some similarities?
Yes.
So,
Example of the scale.
exactly. Okay, so let me do the auto scaling if we have to. Right? And let's see, where do we have the maximum expiration, like we checked? The trough? Is that correct? Okay. And if we want to check the volume, where do we have the maximum volume? Inspiratory volume, right? And recall that we checked from this, we checked the FVC, is that not? So from here, if we want to check the FVC, we can also check it by measuring the difference between this point and this point. In order to do those measurements, we have some icons that are here, the point marker and this M. But I think it should be good for us to walk through it together. Is that okay? Now, we have finished the procedure and we did this 3 times. We want to check how we can record do a little bit of analysis. I hope this session is not too boring. Sometimes I tend to run away from respiratory physiology and maybe jump into ECG, which is more engaging. But fine. Now, from the flow channel, recall, are we together? Recall that this has a flow channel. Right? 1.98. So we better go back to 2.29. Alright, so I can call that when I click. Can you see where I'm clicking on?
Yeah.
So when I click on this, it takes a scan. And the value is there. I know what to do, but let's read through it together. Now, place the point selector on the peak maximum value in the flow channel. This will display the PRF in the flow value panel. In case you don't know what value panel means, if you click that, you will get a direction. Right, so, I mean, there's some noise there, and it seems we picked it at the highest point of the noise. I mean, this kind of zigzag thing, we call it noise and tracing.
Yeah.
So, but let's work with what we have to save time. So, peak inspiratory flow, we have it at 2.1 liter per second. The next instruction is to check for peak expiratory flow. That's a reminder that our time is getting up. So peak expiratory flow. Now we want to take the point selector to the trough. Can we remember that expiration will give us a negative value? Yeah. So we want to take the point selector to the trough, and we can make this a little bit clearer. Put it here. Do we agree that's the lowest one?
Yes.
Our reference point is the flow, so do not be confused by the other volume and rate channel. We are looking at flow. And then the value that we have, we drag and drop as our peak expiratory flow. The next one is time for first vital capacity.
Why is it negative?
So because expiration is a negative value. Inspiration is a positive wave. As you breathe in, we have a positive wave, and breathe out, there is a negative wave. Right? So that is the negative wave that we have for peak expiratory flow. And we have placed it there. We want to check, yeah.
I guess I should know how to get the time.
Yes, so we want to get the time for first vital capacity. I hope you understand what that means.
Yeah.
Fine. So to get the time for first vital capacity, now we have to make our reference to the volume channel. Remember, we have been using the flow channel. Now we are coming to volume channel. For that, so in the volume channel, I think we should just stay where we are. We had 3 readings. We wanted to look for the one with the greatest, but to save time, we can stay where we are. And we place the point selector at the end of the plateau. I mean, we understand that this is the plateau, is that not?
Yeah.
So take a point selector there, and our gaze is on the volume channel. So just before the stick crease. Good. Are we together? That is one. Then the next thing we need to do, we need to place a marker. So we want to compare change. So we need a reference point between one point and another point. So we place the marker at the point of maximal expiration. Can you remember where we selected as maximum expiration the other time? Yeah, so we take, this is the marker M here, and we are dragging it. It has a small black dot. I don't know if it's showing there. Yeah, perfect. Can we agree on this spot? Yeah, so when we keep this, the system will measure the difference between this point and this point. Does it make sense to us?
Yeah, do it by its own.
Yes.
Just
So-
have to have the marker and the pointer.
Yes, the pointer here
And
and the marker here. We get the time difference. But in case you want to look at it manually, you can see that this is 1 minute. This is 105. I mean, I can just extend it to, I can keep extending it so we can have smaller values. But the system will give us that. And we have a negative value because it's reading it in reverse. So if I move the marker up here and move this one down, we'll get a positive value. But let's follow through and see why we have done it this way. Right, so the time to expire all of the air from highest to the minimum it could get. Sorry, now I'm jumping the instruction, but it's good for us to follow the instruction. Good, sorry. This should be taken here, right? And you can see this icon that needs change. So we're looking at a reference point, right? So we're through with this volume channel. Enter the values. That's what we've just done. First expiratory volume in 1 second. Can you remember that we can check this for the first second? Right, so in order to do that, we leave the marker, the point selector where it was. We take the marker 1 second to the right. And just in case you don't know how to do that yet.
Yeah, I was asking how to do it.
Exactly, so just in case you don't know how to do that, you can click on this and it will show you that this was where we have our point selector. And this is the marker we want to look at 1 second to the right. So this change in time is in -1 second. So you can use this panel to look at it. Or we can use, we can extend this one. Okay. So such that we have 44, 46. So between 44 and 46, we know it's 45, is that not? So it's now for us, pardon? So what I meant is, this is 44, therefore this point here will be what? This is 46, so this point will be what? And this is 48. So we can identify, we can estimate 1 second because we want to check something in the first second. So now we can look for where we have our marker because I've just altered it. Good. Now we can see that our marker was here, and if one box is 1 second, it means that we need to take our marker here. Do we agree?
Yes.
Good. Right. So I mean, this is very little fraction there. So pardon my inaccuracy, but yeah, try that again. Perfect. Right, so going with the instruction, enter the value from the volume panel into the FEV1. So here, we are looking at the volume of air, or in the volume that is expired in the first 1 second. What is the relevance of this? For individuals that have obstructive lung disease, the volume that is expired in the first 1 second will be impaired. So will it be increased or will it be reduced? Good. So that's the first thing we're looking at, and we have been able to extract that particular value. Right? Pardon?
How to get
Yes, so that's the next one. So first expiratory volume in 1 second. Or did I skip something? Yes. So the first vital capacity, again we're looking at volume. In the volume channel, we want to determine, but we're staying with this particular reading. And take this to the plateau. Remember how our volunteer breathed, that he had to breathe in to the highest capacity, held for 1 second. That 1 second is this plateau that you find here. Does it make sense to us?
Yes.
Good. So we want to put this on this plateau. That's because that is the volume as of the maximum inspiration. And remember what first vital capacity means. So we want to work that out. We will take the marker to where he had the maximum expiration, because we want to look at the difference in volume from where there was maximum inspiration and when there was maximum expiration. Does it make sense? So that difference is what we want to look at. So this marker now, we take it to the trough, the lowest. Well, do we agree with me that it's around here?
Yeah.
Yes. Good. We're looking at the volume, but going with instructions so everybody can follow. We need to enter the value from the time and volume value panel. So when they talk about this is flow panel, if you want to take reading, this is volume panel, this is time. Right? So the first vital capacity would be 4.4. And yeah. So I hope we can make some sense. Are people waiting outside?
Understand? Are people waiting outside?
Yes.
For how long?
That's from the other section.
Sorry? No, I've been waiting here for like 10 minutes.
Okay. You attended.
So you're through with one session?
We've come from ECG.
Oh.
Yeah.
My sincere apologies, ladies and gentlemen. I mean, I didn't notice that. But the next thing that we could have worked out is to make sense out of these values that we are taking, because part of what we do in pulmonary function test, we check the ratio between FEV1 and FVC. And the next activity would have been to simulate asthma. So this time around, we would have opened this one up and then use a tape to cover it and then put a puncture. When we put a puncture, that would simulate a constricted airway and repeat the test.
Okay.
Then we can have a look at the,
Maybe we'll go for the other one. Maybe when you're about, if you finish before you, when you're about to demonstrate,
Then we have a larger,
we'll join you.
perfect. Good.
It's
So,
very
thank
good
you.
to see the essence in you.
Thank you very much, and
Thank you.
our dear volunteer, I think,
How can we find them?
So let's
Yes.
look like this.
Okay.